So many of the buildings that I've worked on have their, even the outside of the building, the facade of the building is very sculptural because I like the lights, the way that the lights and shadows play all over the facade, and then how you touch it. I'm also very particular with material honesty, especially in places where you can touch the building. I like something that looks like wood to be wood. I like something that looks like stone to be stone. I like that and that honesty.
Hey everyone, thanks for listening to another episode of Buildings 2.0. Today, I'm speaking with George Kontaroudis, Principal Architect at KWH Architecture. George, thanks for chatting with me today.
Thanks for inviting me, Jose. Glad to be here.
Bring us back. So before you were a big-time architect, before you worked at fancy firms, and then you ultimately started your own thing at KWH Architecture, you were just a kid in Greece. And talk to us about the experience of growing up in Greece and then, how that led you to study architecture.
So growing up as a kid, I had lots of influences of architecture because my dad's an architect too. He's an architect and town planner, and he was part of the Middle East boom. So he worked a lot in the Middle East, going to Saudi Arabia, to Libya, to Iraq, to all those places, and building new towns. So his stories of those exotic places were kind of, I was being amazed by those stories, and ultimately I wanted to become an architect myself as well because I wanted to live the same experiences.
Did you find yourself working under him in the early days, or did you get catapulted into college to study it? I mean, how was that jump from as a young kid into academia?
So I went straight to, after school, I went straight to college, and then where I loved architecture. I'm going to be frank, I was a terrible student at school, but as soon as I went into architecture school, everything kind of clicked in the right place. And I excelled. I was a terrible student at school, but I was the best student at university because I got it. I was able to understand architecture. And once I graduated, I started in the UK. So once I graduated, I moved back to Greece. At the time, there was a big building boom. So I was very lucky to work on some great projects, which, in all honesty, I was unqualified to do so, but it was before the Olympic Games, right before the Olympic Games in Athens, as in every place in the world. Once you have such a building boom, everybody gets to do stuff. So I was inserted into doing amazing projects as an intern, pretty much, or as a very very young architect. So I rode that wave for a while with large firms in Greece, and then joined my father, and we kind of opened together an architecture practice. We did some projects in Greece, and also I worked very closely under his guidance doing a master plan in Jordan, which was my first master plan. And then we did a second one in Pakistan. And kind of, I realized that urban design is not for me. I prefer architecture. I prefer the buildings than the large scale stuff. So that kind of led me away to move into buildings themselves rather than.
Is it the scale? Is it the process of designing a master plan versus a building? Or what draws you closer to architecture?
I couldn't see the human connection. I think it was way too detached from, although there is a connection in urban design, definitely, but I just couldn't see it. I want more tangible stuff.
In that, what do you consider to be some of the biggest influences for you, whether it's people or just experiences, whether traveling to different cultures? What influences how you approach architecture today?
Traveling for sure has influenced me in a way that the more that I've traveled, the more that I've seen how similar people are and how similar people's needs are everywhere around the world. But I use my senses when I experience a building. So I use the same senses when I design a building too. So I pay attention to how a building sounds on your insides. I pay attention to how the door handle feels when you enter a building, how the doors sound, how the floor feels, which is extremely hard to translate into drawings, right? But it's that feeling that I'm trying to get from my buildings as well, like the touch. I like the not just the not just what you see, but what you touch as well. So many of the buildings that I've worked on have their, even the outside of the building, the facade of the building is very sculptural because I like the lights, the way that the lights and shadows play all over the facade, and then how you touch it. I'm also very particular with material honesty, especially in places where you can touch the building. I like something that looks like wood to be wood. I like something that looks like stone to be stone. I like that and that honesty.
Tell me a little bit more about that. I mean, are there buildings that stood out to you, whether growing up or even recently, that stand out as like, this is an example of what I consider to be successful in architecture?
That is a very good question. And I would say that, when something is right, you just feel it's right. You feel comfortable with it. So it doesn't really stand out. But when something is not right, it stands out.
Right.
So I particularly remember every day coming back from school, walking home, there was a house that was like a big villa close to my school that had beams out in the air, and those beams were clad in marble slabs. But it was so obvious that they were marble slabs with a huge bolt in the middle that it didn't seem right to me. It didn't seem right that marble was being suspended like that. So I think that was one of the very, very first examples that made me think, hey, hang on a second. This is dishonesty in the use of the material. And it doesn't feel right to me. So that kind of drove me in a way to be more honest with material and with my detailing. Like, for example, like for the previous firm that I worked, I did a brick building that was done as it was prefabricated, it was precast, but I made sure that all of the brick details actually resemble how that building would have been built with actual bricks one by one. And the final result, the building has just opened, it's operational now. You can't tell that it's not a hand-laid brick building. And I think that's the success of, I faked it, right? I faked it, but it was done in a way that we never had, for example, any huge cantilevers with brick. Any huge cantilevers were done with metal, just because I wanted to maintain that honesty. And I think I was successful.
For the general public who's more of a casual observer, why do these concepts matter, right? So like for the casual passerby of a building, the material honesty, which I find like such a thoughtful concept that I think we should keep in mind in the design process. Why should it matter for the casual passerby?
That's a very good question. And a very tough question. I guess it should matter because we as architects craft the world that we live in, right? And I think that material honesty makes you feel comfortable in a city. Like the same way, like how I like one of the drivers of my architecture is also contextuality. I love doing contextual buildings. So although my process wasn't like that before, working for the past two architecture firms that I did, I learned to do a very good precedent study and then a study of the immediate surroundings of a building and try to design something that fits into its surroundings, which is the urban environment in most cases that I work in.
In a large part of your work, passive house and sustainability, both of which are not necessarily new concepts, are important for your work. Perhaps going to the previous question again, why does it matter to make sure that sustainability and passive house concepts are embedded within the design process for, say, someone who's just getting started off in architecture, understanding this?
So I'm going to say I might be a bit boring and a bit nerdy, but one of the facts that I always say when I talk about sustainability and the importance of sustainability is how impactful buildings are to global CO2 emissions. Right, buildings are responsible for about 40% of global CO2 emissions. That is a huge number. In big cities like New York, for example, that number goes up to 70%. So 70% of the CO2 emissions of New York City come from the building and the operation of buildings. So we had a huge responsibility to reduce that. I was always interested in sustainability. from my second year of architecture school, I had a professor who introduced us to the concepts of building performance and energy modeling. At the time, everything was done by hand, right? So it was very, very basic. But until that point, I wasn't aware that buildings could do that buildings could perform. And that kind of sparked my interest into the performance of buildings.
I'm curious to learn more about this. So what are the ingredients, right? So to me, when designing and building a building, it comes from the various ingredients that we use or decide not to use. What should a better building look like? And what are some of those ingredients that should be thought about and used in buildings of the future?
So I think a great building should look whatever you want it to look like. It's completely up to the designer. And Passive House, which I'm a huge advocate of, is style agnostic. You can do whatever you want, as long as you follow certain principles. Like one of the principles that we follow is that the envelope, the skin of the building, is properly insulated, not over insulated, not under insulated, just properly insulated, airtight, and has good components. And once you get a good envelope for the building, then your mechanical systems need to be so small that the energy that you're using to create a comfortable and healthy indoor environment is minimal, right? So it's very easy for us. We know how to get buildings to have almost, you can't ever have zero, but almost zero.
This is just to double click on what you're already mentioning. This to me is fascinating because the math of decarbonization often keeps me up at night. And by that I mean, I think the number is something like 1.6 billion buildings out in the world. And to your point, these buildings represent 40% of these emissions in the environment. And basic math, if in fact we have to somehow get from today in 2024 to about 2050, what is that, 26 years away, we have to do something about it. We have to improve these buildings. The math is quite daunting. Even if you consider that, percentage of these need to be improved, we're talking about hundreds of thousands of buildings per day that need to be somehow improved from now to then, if we intend to be timely and successful in improving the window systems, the envelopes, the HVAC systems. This keeps me up at night. And so I'm actually fascinated to double click into this. Do you have a sense as to what can we as designers, architects, engineers, builders do with the existing stock of buildings? Like, is it just a combination of just better insulation, better windows, HVAC systems need to be swapped out? I mean, how do we even begin to wrap our heads around tackling this challenge?
We have a work plan to get this done, but we're not doing it as a society fast enough. And the building decarbonization includes the full electrification of buildings. So the removal of fossil fuels, no oil, no natural gas burning in buildings anymore, just electricity. But the most important thing is to reduce the electricity demand that we need to maintain and improve our quality of lives inside buildings. So that includes insulation, airtightness, good windows, and of course, dealing with the ventilation of buildings. I mean, I'm seeing that in many cases, people try to improve their buildings by adding great windows and good insulation, only to find themselves stuck inside airtight buildings with no ventilation. Right? An integral part of passive house design is continuous mechanical ventilation. If you don't have that, you have mold. You have high CO2 levels inside buildings. And many of the retrofits that are happening that are not taking that into account have those problems. So we tend to blame the bad performance of buildings to the insulation and to the good windows that we're doing. But as a matter of fact, we're not doing the job properly.
If I'm understanding this correctly, it's because materials and the correct selection of materials and the design of the envelope is one part of the puzzle. But you're suggesting that the layout itself of the building right? In terms of how it enables proper ventilation is another side of the coin.
The layout itself is another side of the coin, but I'm talking about mechanical ventilation. So passive house buildings, for example, they need to have a mechanical ventilation system that works 24 hours a day. Because you have such an airtight envelope, you need to get air in and out. But anytime you do a new building, that's not a passive house, but you still use kind of contemporary materials, that makes it more airtight than the buildings of, 50, 60 years ago, which air was leaking in from everywhere, right? The moment you do that and you do not add mechanical ventilation, you create a problem inside the house. For example, last week I was back in Greece. I'm designing a passive house there, and we had the passive house certifying team come over to do the blower door test, which meaning that we need to kind of evaluate whether the building has been airtight enough or not. So as soon as they arrived, I took them to their Airbnb, which was an old house, but was recently renovated, had good windows and stuff. The moment you entered the building, the house, you could smell the humidity because it had good windows that, double pane windows with gaskets that would seal the building, that would seal the house off. So you could smell the humidity. My parents have also a house on the island that was built 45 years ago, doesn't have any insulation, has single pane windows, is terrible in terms of performance. But as soon as you walked in, there was no smell because the building itself was so leaky that air was coming in and out. Now, that's not a great building. It's a terrible building because it's extremely hot in the summer and it's extremely cold in the winter. But it has fine amounts of air coming in. I'm not going to say good, just fine amounts of air coming in and out of it, right? So it's critical when we're thinking about doing new retrofits or new buildings to think about mechanical ventilation. A window opening a window is never going to be enough. And it's never enough because you will not open the window if it's snowing outside, if it's raining outside, if it's windy outside, if it's noisy outside, or if it's dangerous outside. Or if it's too hot or it's too cold, right? But if the conditions are ideal, you'll open the window. Are you going to do that for 24 hours a day? No. You're going to do it for an hour or two a day when you're home and when it's safe to do so. So what are you doing the rest of the time? Nothing. That's why we're huge advocates of mechanically ventilating buildings, because we can ensure the correct indoor air quality inside.
It's hard enough to be able to design those systems. How then do you communicate that to the other side of the table with a contractor who sees the vision and understands that it sounds like you're currently building a passive house now. What is that process like? And how do you go from design to execution?
Well, thank you for that question. That is great. And I've been trained as a passive house designer in the US, right here in New York. So the techniques that I know are US based. So when I went to do that passive house retrofits in Greece, I was coming in with what I knew as what makes a good building, what makes a passive house. But I went in with an open mind, and I went in with drawings to talk to contractors and see what they think and how they think they can do it. And I can tell you that the drawings and the details have changed dramatically. Like my first iteration, the one that I went in with, to what we actually built, they're completely different. Because I wanted to hear from the contractors what they were comfortable in doing. So what we ended up doing is using traditional techniques to achieve our airtightness and our insulation levels. Nothing too exotic, nothing too fancy, something that they could do. And as a result of that, the contractor, who had never done a passive house before, and was so stressed about whether he could achieve the airtightness that I was mandating to him, he actually achieved it. We achieved the airtightness. So the building is airtight using traditional methods of construction that we do in Greece.
Give me an example. So this is fascinating because what it suggests is that it begins to open up for a traditional construction industry that it is in fact possible and under the right conditions and understanding. I mean, what's an example of, say, a traditional building technique that they were able to employ?
So we traditionally do air tightness here in the US either with membranes or with liquid applied membranes, right? But what I found out is that lime plaster has the same properties as an air tightness membrane if it's done properly, if it has the right amount of lime in it. So lime plastering buildings is something that is traditionally done in Greece. So that's what we did. Our air tightness barrier is lime plaster. I mean, the difficulty with lime plaster is that you can't get every surface, right? And you can't get into the nooks and crannies. So that's the only point where we got a bucket of a liquid applied membrane to get into those points that we couldn't get with the lime plaster. But that's it. That's it.
Right.
And that's a great example of a traditional material used for something advanced.
Now, be honest with me, like in that process of communication with the contractor, did you find that just simply being there on the site and making those game time decisions was necessary? Did you find that using, different visualization techniques, whether 2D or 3D, was effective to communicate it? What were all the different techniques to make sure that somehow you were executing and communicating really to the contractor? What was effective?
So I wasn't there. I was doing all of CA from right here in Brooklyn. I only visited the sites twice. So I wanted to communicate the information as clearly as possible. So my construction documents, for example, I deliberately chose to have only like three key details. Because if I overloaded them with details, they'll get lost, right? Then I created a series of diagrams, of step-by-step diagrams of how to do something. I included photographs from manuals that tell you how to install certain things. And the most important thing was having daily calls with. So I had an architect that was working to oversee the project over there, and she was not familiar with Passive House, but she wanted to learn Passive House. So I was having daily calls with her. She was sending me photographs, and I was commenting on the photographs and sketching on the photographs and doing very, very simple drawings of how to do something. And I think that the critical thing about both the supervising architect and the contractor was that they, and me, right? None of us came into the game thinking that we know everything. So all of us were willing to listen to one another. And we did. And that's how we were successful, by listening. And yeah, that's so important. I can't stress enough how important it is to never think that you know everything. You don't know everything. None of us knows everything. We can always learn from other people.
I think that sense of humility going into a project, we're kind of reminding ourselves that we're all just trying to figure this out, and all students of the game is, to your point, an important perspective. So designing is hard enough. Executing on the site is hard enough. How do you begin to have these conversations with a client, right? So are we still in days where, yes, it does cost more or take more time to build a sustainable passive house than a non-passive house certified project? Is that still the case? How do we have that conversation with the client to talk about what are the long-term benefits, et cetera? How do you approach this?
So as far as cost goes, doing a passive house can be more expensive or can be cheap, can be less expensive than doing a conventional building. It all depends on who you get to do the work for you, right? Who's your designer, who's your architect, and then who's your contractor. Passive houses can become less expensive to build than conventional buildings if designed properly from the beginning. If your initial goal is passive house, right? Just because you have such a smaller amount of mechanical equipment, the mechanical equipment needed for a passive house, they are minimal. They're so incredibly small that the cost just of eliminating that equipment drops significantly. And when it comes to the client, my approach has always been that, not always, it has recently been, because I was, in the beginning of my career, I was kind of thinks like most architects or most professionals think that you know everything when you're young, right? When you graduate, and then you realize that, hang on a second, I don't know everything. I have still a lot to learn. And the older and the more experience I get, the more humility I get, and the more I'm willing to learn and communicate and hear other people, right? So being able to hear what your clients' needs are, what they want, what they need, and try to fulfill those can help you get them to a point where they can get a passive house with either the same or lower cost than a conventional building.
In the recent months, AI has been at the forefront of a lot of conversations, AI in real estate, AI in design. In your own day-to-day, how do you think about the impact of AI? Has it made its way through the way you think about your workflow, completely disregarding it? How do you think through some of the impacts that it has on your workflow and then ultimately the built product?
Yes, indeed. We have been talking a lot. AI has kind of entered our work. I have used AI. I've had higher expectations for AI that haven't been met yet. So in the previous firm that I worked, I was head of the sustainability committee. And part of that, I was kind of evaluating programs as well. And at some point, we went into the task of evaluating how we can use. I don't think it's AI, but it's more like parametric design, like which is called AI. How we can use that to minimize the time that we spend during the massing stages of a project. Because I've had many cases where I was sort of designing the building and we're doing different massing iterations, and each massing iteration took an extremely long amount of time because you have to calculate the square footage and the unit mix and this and that and make sure that it's right. Now, what if AI could do that for us? I don't think that AI can design good buildings. I think it can definitely design barracks, can definitely design buildings of like pure functionality, but you need somebody who can evaluate the results of what the program is giving you. So we found the problem and the paradox that, usually you get junior staff to do your massing studies and then you evaluate them, right? But because doing that with AI programs is so fast, somebody who's junior doesn't have the knowledge to communicate with the program quick enough or efficiently enough to get the right results. So I realized, and I might be wrong with that, I don't know, but that was my impression by using it, that I am the one who needs to be giving the prompts to the program to evaluate what it's giving me back. Otherwise, it's still a waste of time. And the other thing that I was questioning, and I was questioning why it's called AI, is that I asked some of the people who were developing those programs, like, are you learning from what we as architects are choosing as options? If you're giving me 50 options for a massing study, right? And usually like 45 of those are going to be garbage. And 5 of them are going to be good, right? And 1 of them is going to be great. But sorting out the garbage from the good stuff is a human's job. It's an architect's job. Now, if the program was learning what architecture firms were choosing, then it would evolve. It would stop giving me 50, 45 junk, and would only give me 30 junk, 20 junk, 10 junk, right? But from what I understand, they were not doing it yet. Maybe they're trying to do it now. I don't know. But I think the communication between the users and the program needs to happen. That's for the massing, right? I mean, I've tried to use those programs for sustainability, to meet sustainability goals in terms of optimum volume to surface ratios and orientation to take advantage of the wind and stuff like that. And I think we're going to get there. But the most important thing is to know the right questions to ask to get the right answers back, right? I'm also teaching an energy analysis course at the University of Oklahoma. And the first thing that I tell my students is that you need to understand how buildings perform to ask the right questions. If you don't ask the right questions, you're not going to get back the right answers. So I think it's the same thing with AI as well. You got to ask the right questions.
For a young George, now with many years under your belt of experience as an architect, as a teacher, what would you tell young George coming into architecture, knowing what you know now, what should a young architect consider as they step into an industry and what they can expect in 5, 10, 20 years?
To be open to change and not to be stubborn and always keep learning. The moment that I meet somebody who tells me, well, we've been doing this way for so long, so I'm going to keep doing it this way, they can't be part of my team. So I think, and I'm happy that I always did that. Anybody who's new in the industry, like, try to see what's not working or what you can improve and improve that. And at the same time, try to learn. Don't be stubborn with your ideas. You could be wrong. I could be viewing this interview 10 or 15 years from now, and I could be wrong. And I'm acknowledging it right now that my opinions now might be, I might see them as wrong in 10 years from now, but that's fine. That's evolution. That means that I'm going to be a better person in 10 years from now.
Which begs the question, and I guess the last question is the ironic paradox of this is we're often asked, what 5, 10 years from now, and then the honest answer is I don't know. And sure, you don't know either what different tools and software and technologies we're going to be using, but it begs the question: what is likely not going to change in the way that we think about our buildings? What a successful building is. What is likely not going to change in 5, 10, 20 years from now about architecture in our buildings?
I think that what's not going to change is the way that we occupy the buildings. I don't see happening such a huge cultural revolution where we don't occupy. Each family has its own apartment right now. I mean, that's what we consider to be in most of in the world that we work in, right? So I don't think that's going to change the way that we live our family lives. Maybe our buildings are going to become smaller. Maybe they're going to become bigger, our apartments. I don't know. But I think that's going to remain the same. Maybe not. I don't know. I'd be very interested in seeing and seeing how things change. That's why I also like science fiction movies, right? Because they challenge the way that the future is, and sometimes in completely crazy ways.
And with that, George, I wanted to thank you. Incredible conversation, and I can't wait for part 2.
Thank you so much for having me here, Jose, and looking forward to part 2 as well.